Hello, Professor. We're week 7, and I'm going to just start reading from my notes like I always do, and we'll get through this. So, the summary. Safety, as always, know where my extinguisher is. This week we didn't have any very volatile or hot issues we had to deal with. Just the chemical breakdown reaction between the vinegar and each reactant, lemonade reactant, sodium bicarbonate, and the sodium carbonate. So I still, as always, area was clean. My exits were available, and my fire extinguisher was under the sink as always. Oh, and I did it at midnight last night, so I had nobody to deal with as far as knocking the flask over. So, clearly state your experimental results, including directly showing the reviewers the outcome of your experiments. If that's to be the pictures that I'm going to send to you via email, I didn't take any other pictures or videos of the experiment while I was doing it. However, on a note, I did read your warning about not using the cylinder, but I forgot about it until it was too late. So I had to rerun the first experiment over again because I didn't use the beaker like you had told us to. So that was interesting. So my average experimental volume per mole of carbon dioxide. My average for the sodium bicarbonate was 11.5 liters, and my average for the volume of sodium carbonate was 14.4 liters. My percentage of error for the sodium bicarbonate was 48.88%, and for my sodium carbonate was 35.71%. I'm assuming that is so high just because of when we add the reactant, the sodium bicarbonate or the sodium carbonate, to the acetic acid, the time it takes us to close the flask back off, we lose a lot of CO2 because that reaction happens immediately. Sources of errors. The amount of CO2 that escaped while the stopper was off during the mixing. So like I just said, I think that was a source of error. And also, I feel like we didn't get a true reading of the volume displacement because we were using 200 milliliters of liquid, and our 6-inch rigid tube did not go all the way to the bottom. So it only displaced enough fluid to reach to the bottom of that rigid tube, and then there was no more fluid to displace because it was no longer submerged into the fluid. So I feel like that was an error, and I kind of have a feeling that if we had used more distilled water and a longer rigid tube, that we would have probably displaced more water with our reaction of 25 milligrams or milliliters of the acetic acid and the carbonate and bicarbonate. So, vapor pressure played a part as the displacing agent. The amount of pressure pushed or displaced an equal amount of liquid. So, like I said, though, I don't think that we got a true measurement on that because of the lack of the length of the rigid tube and the amount of liquid we used, because the reaction was still continuing on after it already pushed out the 150 and 149 milliliters respectively between the two limiting agents. So the mass of the limiting reactant will affect the molar mass or gas volume by way of the amount of moles produced. Once the reactant runs out, the reaction will stop producing moles of CO2 gas. Therefore, the volume of the gas will stop at that point. That is to answer the role, critical thinking, the gas producing reaction, what effect does the limiting reactant mass have on the molar gases. So obviously when the limiting reactant runs out, the reaction is going to stop, and therefore we stop producing results. Finally, my self-reflection. I was kind of having a hard one with this because I don't really know where this would actually go into my personal and professional life, other than the tire thing, living in the cold. We all know here, growing up, that when it starts to get cold out, check your tire pressure, because your tire pressure goes down. We know that, and we also know that in the summertime, when it starts to heat up and the roadways are hot, our tire pressure goes up. So it's going to affect our gas mileage and our fuel mileage. In the Midwest here, we're pretty true to that, and we check it. We're kind of raised knowing that. So I kind of went this way. I'm not too set on this, but I have learned that the temperature will have an effect on most everything that happens. I work in a weld shop. We have over 500 welders running at one time. We weld up steel telephone poles. We make them. And one thing I've noticed recently is there's a lot of preheating of the steel before they weld. And I was told that they do that because it creates a lot less stress on the steel. So bringing that steel up to a certain temperature, they say right around 250 degrees, then they can weld, and they get a lot less stress fractures. They get a lot less slag or reciprocity or undercut in their weld by preheating that steel up. On a molecular level, it reacts differently, and they can get a better weld on it that they don't have to go back and fix. So this is kind of leaning into the whole temperature versus pressure thing. The higher the temperature, the less pressure when they're welding. So it creates a better and stronger and a more professional weld that they no longer have to go back and fix. Not sure exactly if that goes into it, leads into it. I will show you this real quick. Not sure if you can see this, but this is my calculations for the one reactant, and this was my calculations for the other reactant. That might show up backwards, I'm not sure, and I'm not even sure if I need to show you that, but to show you that I was doing my best. Anyway, thank you, Professor, and let's get started on week 8. Bye.